This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at adding, subtracting, and multiplying radical expressions. Now, these first ones, adding and subtracting, are just based upon concepts we've talked about over and over, and the multiplying radical expressions we've seen in a different lesson also. And it's just based upon the fact that if you got two radicals with the indexes the same, you can multiply what's underneath the radicals. So let's take a look at our first problem here. We got the 9 cube root of x minus 4 cube root of x. And subtractor, add or subtract is indicated. Assume all variables are greater than or equal to 0. Now, different books call this different things throughout algebra. Some talk about combining together like terms, like radicals. Really, it should be a like property. If you got two things that are alike in some manner, see how these both have a cube root, then you can add or subtract the numbers that are out in front. Since these radicals are the same, 9 minus 4 gives us 5 cube root of x. And it's even more than just having the radicals the same. You could have something in front of these also. Just as long as they're alike, whatever they might be, then you can add the numbers that are in front. And you'll see this throughout math. If we were going on to trig. Not saying you're going to, but if you had this. Now, the fact that you have no clue what this represents and what this represents, unless you've seen trig in some sense, doesn't matter. They're the same, aren't they? So 9 minus 4 would give us 5, and that's sine, by the way. So we'd have 5 sine x. So again, I don't really like it when they try to give it individual names to all of these, because really it should be like items, the like items property. Let's take a look at our second one here. We've got 3 square root of 5 plus 2, the fourth root of 5, plus 6 square root of 5 minus 8 fourth root of 5. Now all these are radicals, and they all have 5's in them. But notice some of them look different. This has an index of 4, and these are just square roots, which means the index is 2. So we're going to combine this one and this one together, because they're exactly the same except for the number out in front. 3 plus 6 gives us 9 square root of 5. Now over in these, we got the fourth root of 5. That's the same as this fourth root of 5, which means I can add or subtract the numbers that are out in front. 2 minus 8 gives us negative 6 fourth root of 5. And we can't combine those together because they're not exactly the same. They have to be exactly alike for you to combine them together. Okay, let's look at our third example here. Got the cube root of 16 minus 6 cube root of 2. Well, it appears like I can't do anything with these because they're not exactly alike, but the 16, if I looked at prime factorization of that, that'd be 2 times 2 times 2 times 2. So we got 4 2's. Now our index is 3, which means looking for a set of 3 of something. Well, here's 3 2's. So those 3 2's are going to come out in front as a single 2. So we have 2 cube root of 2 minus 6 cube root of 2. Well, now notice that these cube root of 2's are exactly alike, so we can add or subtract the numbers that are out in front. In this case, 2 minus 6 gives us negative 4 cube root of 2. Let's take a look at this one. 7 square root of 45 x to the fifth plus 3x squared square root of 20x. Well, obviously these aren't the same, but we can do a little bit of simplifying. 45, that's 3 times 3 times 5. And 5 x's, I'm going to write them out, though we know there's a shortcut for that we saw in a previous lesson. And plus 3x squared, square root of 20, 2 times 2 times 5 times x. Now remember, with the square root, this is square root because there's no number in a slot here, no index. With the square root, we're looking for a pair of somethings. Here's a pair of 3's, that's going to come out as a single 3. Here's a pair of x's, that'll come out as a single x. And here's another pair of x's, that'll also come out as a single x. So we're going to have 7 times 3 times x times x. And we're left with a 5 and an x inside. Now our other radical over here, we got pair of 2's. Pair of 2's is going to come out in front. So we got plus 3x squared times 2, and we're left with a 5 and an x inside. Now 7 times 3 is 21. X times x is x squared, square root of 5x, plus 3 times 2 is 6, x squared, square root of 5x. Notice, x squared, square root of 5x, x squared, square root of 5x. They're alike, aren't they? They're exactly alike, so we add the numbers in front. 21 plus 6 gives us 27. X squared, square root of 5x. Again, it should be called like a like items property or something like that. It's more than just like radicals, like terms. It's anything. If they're the same, you can add or subtract the numbers that are in front. Okay, let's look at this problem. Got 4 cube root of negative 7x to the third plus 6x cube root of 189 plus cube root of 56. Obviously, these radicals are all different. Well, to begin with, this first radical, it has an odd index, and we got a negative inside. So we know we can just bring the negative and put it out in front. So then we're left with the cube root of 7x to the third, means we got 3 x's. Plus 6x cube root of 189. I think 189 is 7 times 7 times 7, but let me double check on my calculator. I lie. What is 189? 189 divisible by 3. 3 times 63. 63 is, boy, I was really off. 3 times 21. 3 times, I think that's right. Let me double check this. So 27 times 7 gives us 189. Okay, it breaks down that way. Plus, now 56 is 248 times 7. Like that. Okay, well, let's do a little bit of simplifying. Our index, the number in the slot, is 3, which means we're looking for a set of 3 of something. Here's 3 x's, so 3 x's is going to come out in front as a single x. Here's 3 3's, so those are going to come out in front as a single 3. And here's 3 2's, those come out in front as a single 2. So we've got negative 4x cube root of 7. And here we got 6x times 3 cube root of 7. And here we got 2 cube root of 7. And that gives us negative 4x cube root of 7 plus 6 times 3 is 18x cube root of 7 plus 2 cube root of 7. Well, if I look at all these, they all have a cube root of 7. Now, they don't all have an x in front of the cube root of 7, but they all have that, which means I can add what's in front of them. So we got negative 4x plus 18x plus 2 cube root of 7. Well, negative 4x plus 18x is 14x plus 2 cube root of 7, and that's maybe our answer. Sometimes they'll factor out a GCF. See how these both have a 2 in common? And it becomes this. It's hard to say. Different books do it different ways. But I'm happy with that answer there myself. Okay, let's look at this one. We've got the square root of 4x minus 4 minus square root of 16x minus 16. Obviously these radicals aren't the same, but I notice that these both have a GCF. The first radical they have a 4 in common, so I can factor that out. And that leaves us x minus 1. And my second radical, they both have a 16, so I can factor that out, and that leaves us an x minus 1. Well, it's starting to look similar. Now 4 is 2 times 2, and then x minus 1. And 16 is 4 times 4 times x minus 1. Now the reason why I broke it down that way is because we're talking about square roots, which means we're looking for a pair of somethings. Well, here's a pair of 2's. They're going to come out in front as a single 2. And here's a pair of 4's. They'll come out in front as a single 4. So we're going to have 2 square root of x minus 1 minus 4 square root of x minus 1. Now I see that they both have a square root of x minus 1 in common, so I can add or subtract the numbers that are out in front. 2 minus 4 gives us negative 2 square root of x minus 1. And that's our answer. Okay, let me scroll up a little bit here. I'll go ahead and do this one here. So we've got the 5th root of 32x squared plus 10th root of x to the 4th. Now this one has a special note that goes along with it. You see it so seldom in algebra. I usually don't actually write it down. I just try to show an example of it, so hopefully people remember it. Once in a blue moon it actually appears. First off, let's start with this radical. 32, that's 5 2's. And x squared, I could write it as x times x, but I know my index is 5 and I need 5 of them, and I don't have 5, so I'll leave it that way. Now over here, there's a property of radicals that says if you can divide the index and all of your powers inside by the same number, and this index is then at least equal to 2, then you should go ahead and do that. Well, 10 and 4, they're both divisible by 2. 10 divided by 2 gives us 5, and 4 divided by 2 gives us 2. So that becomes the 5th root of x squared. Now back to our first radical. Our index is 5. We're looking for 5 of something. Here's 5 2's, so those 5 2's are going to come out in front as a single 2. So this is 2 5th root of x squared plus the 5th root of x squared. Now notice after I've done this simplification, these radicals are the same, aren't they? So I can add or subtract the numbers that are out in front of them, or add or subtract whatever's out in front of them. Well, here's the invisible 1. So we've got 2 plus 1 gives us 3, 5th root of x squared. And that's our answer. Well, let's take a look at multiplication now. Let me grab a drink here. We've talked about this property before, the product property, so I'm not gonna go over it again. I'll show it with an example. Remember when we had problems earlier in algebra that looked like this? And we used a distributive property? We used a distributive property because the 3 is right next to parentheses, which indicates multiplication. And we took the 3, and we multiplied it times the x, and we multiplied it times the negative 2. Well, this is no different. The fact that we have this radical next to the parentheses indicates multiplication. So we're going to take the square root of 3 times square root of 7 and times this negative 4 square root of 15. So I got square root of 3 times square root of 7 And then I got square root of 3 times negative 4 square root of 15. Well, remember when you're multiplying two radicals and the indexes are the same, you just multiply what's underneath them. So we got 3 times 7, put them underneath a single square root. Now here we got positive times a negative, so that's negative. The 4 just remains. You multiply whatever number's in front. And then we got 3 times 15 inside a radical. Now typically you don't actually multiply them together. You first see if you can simplify before you multiply them. Now 3 and 7 are both prime, so I can't do anything here. So this is just square root of 21 minus 4. And 15 I can break down. 15 is 3 times 5. Well, we're dealing with square roots, so I'm looking for a pair of somethings. Here's a pair of 3s. So a pair of 3 is going to come out in front as a single 3. We got square root of 21 minus 4 times 3 square root of 5. Which gives us square root of 21 minus 12 times 3, or 4 times 3 is 12, square root of 5. Now we can't combine these radicals together because the radicals are different. One square root of 21 and one square root of 5. This is basically merging together the product property you saw in an earlier lesson and distributive property and all those techniques that you saw earlier in the course. Same instructions on multiply and simplify. Now I might be tempted to go ahead and multiply this through, but no matter where you are in algebra, always simplify your radicals before you go on. Sometimes it doesn't matter. You get the same answer either way. Other times, especially when dealing with complex numbers, if you don't actually simplify the radical first, you'll just get the wrong answer. So as a good practice, you should go ahead and just simplify them. Well, 40 is 2, 4, 8 times 5 with an x. We're dealing with a square root, so we're looking for a pair of somethings. Here's a pair of 2's. I guess that's it. So I'll bring the 2 out in front. So this becomes square root of 2x times 7 plus 2 square root of 2 times 5 times x. I might be tempted to go ahead and multiply those back through, but there's no need actually. Okay, now we got a radical in front of our parentheses, so I'm going to take this radical, multiply it times a 7, and times this radical. So I got square root of 2x times 7, and square root of 2x times 2 square root of 2 times 5 times x. Well, remember, you multiply the numbers that are in front, so this one just becomes 7 square root of 2x. Over here, multiply the numbers that are out in front, so the 2 times the invisible 1's 2. And then we multiply what's underneath our radicals. Now, as I multiply these, I'm just going to write them down, but I'm going to rearrange them so the like items are together. So I got 2, 2, 5, x, and x. Again, you know, here's a 2, here's a 2. So those counted for those. Here's a 5, so I counted for that. And here's an x, and here's an x. So I counted for these. Well, the reason why I rearranged them as I was writing them down is because we want to simplify our radical now. And we're looking for a pair of somethings. Well, here's a pair of 2's, so those are going to come out in front as a single 2. And here's a pair of x's, those are going to come out in front as a single x. So this 2 just carries down. This pair of 2 comes out as a single 2, this pair of x's comes out as a single x, and we're left with a 5 inside. So we've got 7 square root of 2x, 2 times 2 is 4 with an x, square root of 5. Obviously these radicals aren't alike, so we can't combine those together at all, and that would be our answer. Let me start a new page. Number 10. Square root of 5 plus 2 square root of 10 times 3 square root of 6 minus 5 square root of 2. Now, there's nothing exciting about this. You've seen this already, this technique. Remember when you multiply these together? X plus 2 times x minus 3? Same technique you use there is what you're going to use on these. So I'm going to take my first radical here, the square root of 5, and I'll multiply it times the 3 square root of 6 and times the negative 5 square root of 2. I'll take my second radical, the 2 square root of 10, and multiply it times 3 square root of 6 and times negative 5 square root of 2. So we got square root of 5 times 3 square root of 6. And we got square root of 5 times negative 5 square root of 2. We got 2 square root of 10 times 3 square root of 6. And we got 2 square root of 10 times negative 5 square root of 2. Now let me double check that, because I was sitting there watching Clint Eastwood slug the sheriff on Joe Kidd versus focusing on this. Let's see. Okay. There's a Clint Eastwood marathon on now. Okay, so let's multiply this together. Multiply the numbers in front. 1 times 3 is 3. Now 5 times 6. Now if I didn't know any better about these, I wouldn't want to actually multiply them together, because I would want to do the prime factorization of each one and see if they have anything in common. Now I know 6 is just 2 times 3, but I'll demonstrate it anyway. Here we got positive times a negative is negative. 5's out in front. And then we got 5 times 2 underneath the square root. Here we got 2 times 3, which is 6. And then underneath the square root, we got 10 times 6. 2 times negative 5 is negative 10. And then underneath the square root, we got 10 times 2. Well, let's do the prime factorization, see if anything comes out. 6 is 2 times 3. Now both of these are prime, so I can't bring anything out, so I'll go ahead and just multiply those together. 5 times 2 is 10. Plus 6. 10 is, what's that, 5 times 2? And 6 is 2 times 3. Minus 10. 10 is 5 times 2. And then that 2 just carries down. Well, after I've done the prime factorization, there's nothing in my first radical here, but in this one I see I got a pair of 2's. So a pair of 2's will come out in front as a single 2. And here I got a pair of 2's, so those will come out in front as a single 2. Now since I have nothing in common here, I'll go ahead and multiply it back through. 5 times 2 is 10, times 3 is 30. So we've got 3 square root of 30, minus 5 square root of 10, plus 6, I'm bringing a 2 out. And then I'm left with 5 times 3 inside, which is 15. Minus 10, and I'm bringing a 2 out. I'm left with a 5 inside. So that gives us 3 square root of 30 minus 5 square root of 10. 6 times 2 is 12, square root of 15. Minus 10 times 2 is 20, square root of 5. And that's our answer. Okay, let's look at this one. Square root of 2x minus square root of 3 squared. Well, remember when you handle problems look like this, x plus 5 to the second power. Remember what you did is you took x plus 5 and you multiplied it times x plus 5. Well, that's what you're going to do here. So I'm going to take the square root of 2x minus square root of 3 times the square root of 2x minus the square root of 3. So we take our first radical here, the square root of 2x, multiply it times square root of 2x, multiply it times negative square root of 3. We'll take our second radical, the negative square root of 3, multiply it times square root of 2x, and times negative square root of 3. Well, we got square root of 2x times square root of 2x. We got square root of 2x times negative square root of 3. Negative square root of 3 times square root of 2x. And negative square root of 3 times negative square root of 3. I'm just following the arrows, seeing what to multiply together. Now, there's nothing in front of these, so I'll just multiply what's underneath the square roots. I got 2x and 2x. And as I write them down, I'll put the like items together. So put the 2's next to each other, put the x's next to each other. Here we got positive times a negative, which is a negative. And I got 2x times 3. And here we got a negative. 2x times 3. And here a negative times negative is a positive. And then we got 3 times 3 underneath the square root. Now remember with the square root, we're looking for a pair of somethings. Here's a pair of 2's, here's a pair of x's. So a pair of 2's is going to come out as a single 2, a pair of x's will come out as a single x. Now notice my instructions here say assume all variables are greater than or equal to 0. They're telling you not to worry about putting absolute value bars around your any variable you bring out. Normally, if they didn't put those instructions, we'd have to put absolute value bars on this x. Minus, there's no pair of anythings here, so I can just multiply this together. 2 times 3 is 6, so we got 6x. Minus, square root, 2 times 3 is 6x. And here we got a pair of 3's. A pair of 3's is going to come out as a single 3. Now always combine together, no matter where you are in math, combine things that are alike. See how these both have a square root of 6x? I'll add the numbers that are out in front. Negative 1 gives me a negative 2 square root of 6x plus 3. And that's our answer. Now you'll notice a pattern here. If you're dealing with square roots, this doesn't apply to everything, but if you're dealing with square roots, if the square roots are the same, see how this was square root of 2x times square root of 2x? See how it just gave us 2x? And this was square root of 3 times square root of 3, which just gave us a 3. It will always work that way where the radical just disappears. And that's assuming you're working with a square root. And the reason why is with this the example I just showed you here. I'm not sure why my tablet's blowing up so much, but at least it always comes up with a fresh version of it without no problem. Okay, square root of 3a plus square root of 11b times square root of 3a minus square root of 11b. Now these ones, they say multiply and simplify, same instructions, but these are actually conjugates. Let's talk about what a conjugate is. A conjugate is when the first part and the last part are the same. The first parts of each and the last parts of each are the same. Quit watching that silly movie. I think it's 2 Meals for Sister Sarah or something like that, whoever it is. See how we have a square root of 3a here, we have a square root of 3a here. They're the same, aren't they? Now let's look at the last parts. Here we got square root of 11b, here we got square root of 11b. See how those are exactly the same. If those are, the first parts are exactly the same, last parts are exactly the same, but the sign in the middle is different. See how this is plus and this is minus? That means they're conjugates. With conjugates, all you have to do is multiply your first parts together and your last parts. So that means we're going to take square root of 3a times square root of 3a plus square root of 11b times negative square root of 11b. Now remember what I said earlier. So if you got square roots and they're exactly the same, then square root of 3a times square root of 3a gives you a 3a. Positive times a negative is negative, and square root of 11b times square root of 11b gives us 11b. This is assuming that variables are greater than or equal to 0. Otherwise, we'd need absolute value bars on a and b. Let's take a look at our last problem here. Got the fourth root of 27p minus 2, and then the fourth root of 27p plus 5. Well, obviously these aren't conjugates. They both start with the fourth root of 27p, but this has a 2 and this has a 5 for our last parts. So we just have to multiply like we did before. We'll take this radical here times the fourth root of 27p and times 5. And we'll take this negative 2 times the fourth root of 27p and times the 5. So we've got the fourth root of 27p times the fourth root of 27p. And we got the fourth root of 27p times 5. Then minus 2 times the fourth root of 27p, and negative 2 times 5. Foiling if you'd have it that way. Now I might be tempted to think that this radical times this radical is 27p, but that only applies when you got a square root. These are fourth roots. So all we can do here is multiply what's underneath them. So I got 27, p, and p. Now the reason why I wrote it this way is because I wanted to group the numbers together and then the p's together. Now here, 5 times that just gives us 5, fourth root of 27p, minus 2, fourth root of 27p, and negative 2 times 5 is negative 10. Now I'm guessing I can do some simplifying on this first one here. So let's see what we got. 27, that's 3 threes, and this 27 is also another 3 threes. And we got p and p. Now these radicals are the same. They both have the fourth root of the 27p, so I can add or subtract the numbers out in front. 5 minus 2 gives us 3, fourth root of 27p minus 10. Well, back to our first radical. We're looking for, our index is 4, so we're looking for 4 of something. Here's 4 threes. These 4 threes are going to come out in front as a single 3. And then, what's underneath here? We're left with 3 times 3, which is 3 squared, and we're left with p times p, which is p squared. Everything else just carries down. Now, there's different ways you can approach this. Let's see. One way, and our second way. First off, notice how this is an index of 4, and this is second power, and this is second power. If you can divide your index and all of your powers by the same number, do so. Well, 4, 2, and 2 are all divisible by 2. So 4 divided by 2 is 2. This 2 divided by 2 is 1. And this 2 divided by 2 is 1. Plus 3, and then the fourth root of 27p minus 10. Which we don't ever actually write 2 there. I just put there to emphasize what we did. 2 as your index means square root, so this is the square root of 3p plus 3 fourth root of 27p minus 10. That's one possible answer in books. The second way you'll see them do it is to just multiply these together. 3 squared is 9, so that's 9p squared plus 3 fourth root of 27p minus 10. Current textbook we use, when they run across these, they actually put both of these answers down. It throws people. They do this, and then they look in the back, and it's like doesn't look anything like that. It's like, whoa, where'd they get that at? They appear to just drop some items, but that's what they were doing. And that's the end of that movie. So let me go ahead and save this.